Hello, my name is Braeden Geibel, and my long term is on roundabout efficiency. So, the question I had was how does the configuration of a roundabout affect the efficiency of multiple vehicle traffic flow? My claim was the more lanes that there are in a roundabout, the more efficient traffic flow will be. The problems I came upon were how are you supposed to simulate a roundabout? How do you accurately move the cars at the same speed? And how do you measure it? So I did a little tinkering around, thinking, writing some stuff down, and I came up with this procedure. So I created a roundabout using wooden building blocks. I set them on a table, created a mock roundabout that could physically move cars around. So I took three matchbox cars of the same equal length to simulate cars traveling around the roundabout. Now, the thing that you have to know about this long term is that you have to assume that the cars are traveling at the same constant rate of speed. If not, there's too much variability going on. So one stick length is equal to one move, which is equal to 1 second. So you would move the car from the one side of the block to the other side of the block, and that would count as one turn, which then equals 1 second. So I simulated 6 different configurations of a traffic flow circle for comparison to one another. So these are the first three I made. So the green dots and arrows indicate car 1, and car 1 will always go to exit 1. Car 2 is blue, and it always goes to exit 2. And car 3 is the red, and it always goes to exit 3. So each one of those dashes is 1 second. There's a little bit of data in there, but I'm going to get to the data next. So after I did those three, I wanted to add another variable in it. So I put in stop signs. Some have stop signs in it, and I just thought that it would add more variability, try to get more accurate data. So this is a video of me playing with it. So as you can see, I'm moving each car to their each destination using the block. So in an ideal situation, there'd be one car in the roundabout traveling to each exit. So in that ideal situation, car A go to exit 1 would take 4 seconds. Car B going to exit 2 will take 8 seconds. And car C going to exit 3 will take 12 seconds. So that's basically the control of the experiment. So I started with the 1 lane roundabout. It took car A 4 seconds to get to exit 1, the same as the ideal. It took car B 8.6 seconds to get to exit 2, and 13.3 seconds for car C to get to exit 3. Now, something interesting you see here is that there's 0.6 like compared to the 8. That's because it takes the car 0.6 seconds to wait for the next car to go. So like for car B, it has to wait 4.6 seconds to get past car A. And for car C, it has to wait that 0.6 seconds 2 times because it has to wait for A and B. So that would add up to 1.2 seconds, which is around 12 seconds and 13.3 seconds respectively. So the 2 lane roundabout took 4 seconds, 8 seconds, and 12.6 seconds. It's basically the same thing. Since there's 2 lanes, cars 1 and 2 would be side by side. They don't have to wait for anything. The car C still has to wait that 0.6 seconds for car B to go. The 3 lane roundabout takes 4 seconds, 8 seconds, and 12 seconds. That matches the ideal situation because each car is going by themselves around the roundabout in their own respective lanes. So then we move on to the stop signs, where you have the 1 lane roundabout with a stop sign with 4 seconds, 11.6 seconds, and 19.3 seconds. It's compared to the 1 lane roundabout normally, which is 8.6 seconds. it has to add on that extra 3 seconds that you have to stop at a stoplight for. So that's why you get 11.6 compared to 8.6 and 19.3 compared to 19.3. So same situation with the 2-lane roundabout with a stop sign. 4 seconds and 8 seconds for car A and B because they don't have to wait for anyone. Car C takes 15.6 seconds to get through because they have to wait for car B. 3-lane roundabout with a stop sign, it takes them all the ideal 4, 8, and 12 seconds again because once again, they don't have to wait for anyone. So here's my graph. As you can see by the graph, the 1-lane roundabout with a stop sign takes the longest, which makes sense because you're adding on 3 seconds anyways at the stop sign. And what I found was basically it doesn't matter if there's a stop sign or not for the 3-lane because each car is going at the same time. In the end, my test shows that the 3-lane roundabout is the most efficient. It doesn't matter if there's a stop sign or not because each car is still going at their own time. But in the real world, there would be too many variables to accurately measure this situation. There could be cars going faster, slower, stopping, changing lanes. There really isn't a real answer because it really just depends on the situation that the cars are in. So with that huge variability, it's basically impossible to figure out the absolute best way that will work every single time. So it really is harder than I expected. And there really isn't even a real answer because it's always just dependent on the cars, the traffic, and everything else. So I did a little more research, a little more digging, and I found this guy on YouTube that made a simulation of cars going around and roundabout. His name is euverus. So I'm going to show you that, and I'm going to kind of talk about that. So this is a single lane traffic circle as shown below. And if you look below, it says traffic flow 8. That it means that 8 cars can get through that roundabout in 1 minute. So it's like a car per minute type thing. So for this normal 1-lane roundabout, it's 8. For this normal 3-lane roundabout, it's 340 cars per minute, which is exponentially bigger than a single lane, which also goes coinciding with my research that I did. So then he went and he also added a larger roundabout, which means you could get more speed in there. And it doesn't really make that big of a difference. It's only 360 cars per minute, but there is some difference in there. So in the end, there really isn't a real answer for this long term. It's way harder than I thought. There's no way that I could accurately represent a typical roundabout because there's just way too many variabilities. But I would challenge anyone to try and find that best one. Who knows? I might do this again next year. Thanks for listening to my long term. Hopefully there aren't any questions.